Hey, hello everyone. My name is Amir. I am co-founder at Vadim. It's a Netherlands-Dutch startup based in Rotterdam. We are making basically AI more accessible and feasible for people and developers coming from non-AI background. But today I'm here to talk about something else. And before that, Tomás, I guess if you guys are looking for one more layer abstract on top of what Tomás just represents, you can also check out ML5.js. This is like a really good abstraction layer on top of TensorFlow and other sort of AI-driven JavaScript framework. This makes it super easy, and then you can also load models, whatever you have. Basically, it's way more easy and more accessible. Anyhow, back to my talk today, and I don't know, I have this weird habit that when I present I need to walk, but now there are two screens, so I don't know which one to focus on. So I will try to be around here, but sometimes there too.
Yeah, try to be in the frame.
Oh, yeah, that's also important. We put it on the blog, right?
That's good, yeah. Stay on your right side.
Cool, great. What I wanted to say, indeed. So, and I wanted to demo, and I'm gonna demo, but the demo is gonna be basically is usually about the solution, and it takes about 1 or 2 minutes. But for me, this talk particularly, I want to focus on the underlying problem and understand the problem and different aspects of it. Then we go into the demo. So sorry if I'm gonna mainly focus on the slides. This is my first time, and sorry, Tomás. I know I did my best, but today, live coding didn't make much of sense, but we still will do it. So today I'm gonna talk about managing UI when it comes to generative data. And I was thinking how to describe generative data, so I was thinking, okay, let's put it against something that we all know, and therefore I'm gonna today talk about generative data versus crowd. Who doesn't know what crowd stands for here? So it's basically one of the legacy API techniques that stands for creation or deleting or updating or the data, right? So these are different types of API endpoints, and usually the way how it works is send a request to the server handles it and send a response back, right? So in order to understand that, we are gonna try to find the differences between these two analogies. But when we talk about generative data, we are talking about a lot of things. We can talk about function calling, chatbots, we can talk about agentic flows, or we can talk about RAG. For the sake of this presentation and to keep it easy and understandable for everyone, we are gonna stick with RAG. And who doesn't know what RAG stands for? Okay, RAG stands for retrieval augmented generation. It's a technique when you are working with large language models and you have tons of domain-specific data and you want to combine this together. Basically, if you want to build ChatGPT on top of your own data, one of the most used techniques is RAG. So the way how it works, you have a lot of documents, a database of documents, or just like, I don't know, data in a MySQL database, MongoDB, or some unstructured data like PDF files, etc. Doesn't matter. So you have this pool of data and user asks some questions, right? So you want, and we call that user prompt. So you want to go and retrieve the relevant information that are related to that user query and take it out, and then along with the user query, provide the context to the large language model and say, hey, based on this data, based on the user query, I found this data. Now combine this together and generate a response for the user, right? This is retrieval augmented generation. I hope I explained it as easy as possible. But now let's go back to, now we know what RAG is, now let's talk about generative versus crowd. The first thing that, the main difference is the workflow. When we're talking about crowd, we are talking about a one-shot process, right? You send a request and then you get a response back. There is one event happening and you just handle the response accordingly, right? There is not much happening on the side of front end and the UI. But when you're talking about something like a RAG, it happens in stages. It happens in multiple stages, and you need to be able to handle them accordingly. meaning that the top part is a diagram of the most simple, the basic RAG. So basically, user query comes in, we retrieve the information. So when you retrieve the information, this is already taking time. So that's the first event happening. Then you need to generate on top of that. So that would be the second event. And then once the data is there, you will start generating responses, which I get to it later. Or it can be a bit more sophisticated. It can be, for example, agentic RAG or adaptive RAG. For example, in the bottom diagram I show it, that in between you also start hooking agents to it. For example, query parsers to understand and extract the intention parameters from the user query to map it against your database to have a better retrieval. Or you can hook into hook a re-ranker to re-evaluate your search results to make it more accurate. Or you can add a validator to validate the response generated by the model. So every one of these, you need to basically let the user know there is an event and you need to handle it in your AI. So that's why we say it's a multi-stage, basically, flow. The second difference is the delivery. When you're working with large language models or any sort of AI models, predictive models, you are dealing with basically drips of data. There are a couple of, it doesn't matter what type of model. It could be sequential, which is the most dominant type of large language models that we currently see, that the tokens comes in a sequential order. Or it can be insertion-based, for example, non-monolithic, non-monolithic models that are highly experimental at the moment. And in these type of models, basically the model not only decides what should be the next token, but also decide what should be the position of that. So where it appears. And you might have seen sort of animations that, the text appears in a very random manner. Those are the type of model. Or it can be like diffusion models, like the image diffusions, that the image progressively gets, better and better and better. But all of these have one thing in common, and that is basically that tells us the data comes drip by drip. We need to control that. We need to take control of that. And the third one is the deterministic, non-deterministic approach when it comes to generative AI, versus when you are working with something like CRUD. In CRUD, it doesn't matter how many requests you make against the database. Billions of the same requests, it's gonna basically result into exact same answers. But when you're working with large language models, every time you might get a different answers. So, and that's why I call the left one fact versus a story, because when you're working with crowd, you get facts. When you're working with generative models, you get a story. So that also, again, it's gonna affect the way how you handle this in your UI. So now we know the differences. Let's look into what are the treatments, what we can do to make it better and better. First of all, context. Context is very important, and you need to keep track of the context. And by context, we don't only mean like, the user query or user prompts and the time or as such. We need to store everything as much as we can. For example, we need to store user query, we need to keep the history and the conversation, the output of the model, and user inquiries, as well as the retrieved data. And all in all, you need to keep track of them, because this is matter. This is how you can manage the state after all. It's your source of truth is this basically combination of all this timeline and all this data that happens over the timeline. The second part that is very important is retry and abort. You know why there is a stop button on cursor, or I don't know, V0 or those sort of things? Because the business model is also different when you're working with generative models. Those models and the business model around them is shaped around token by token. They charge token by token. They charge based on that every delivery they make on your end. So these are the tokens comes in, and this is basically your spending, your cost growth also vertically. So you need to always think as a developer, especially if you're working on the front end, you always need to think about the abort function. You need to make sure that when you're working with large language models and you're dealing with a stream, you need to make sure that the cancel button is there, and you need to do that. Another thing is retry. Again, because the model every time might respond something and the user might not like it, you should always give this option that they can retry it and fetch it again and again. Okay, so that was the slide. I tried to be as quick as possible. Now let's go to a real example. This is basically a chatbot I built on top of the website. The data comes from Embody website. and backend that we are using is also Embody, but that doesn't matter. So this is a chatbot that also generates some suggestive queries, like questions, or I can go ahead and ask question, for example, who are you, and I don't know, what are your data, or what is your data about, for example. And you see, understanding is the first thing. So the first thing happens, then retrieving the data happens next, thinking next, and then you see basically the response. So on every single step of the way, you need to make sure that you are basically providing answers to the user. Let me zoom in a bit, maybe. So let's do it again. When I ask a question, understanding, searching for relevant documents based on and then thinking, which generates the result, and then at the end, basically, you have the entire thing. Another thing that is important, that you need to make sure that you can also stream. Of course, you can also show the last result, the whole generative response. You can hold the user until the entire response is generated, or you can stream it token by token. So in fact, this effect, this animation, that things comes, let me refresh again. So you see the words come one by one. This is not an effect, UI effect. This is part of the API. It comes like a stream. This is how you render it. There's no other way. In terms of code, there is not really much to say, but for example, what I show you is a RAG, and this is how you would make the RAG inside Embody based on you define different agents, basically a query parser agent. I don't know if this is big enough, or I should...
A bit bigger. It's not bright enough, but it's not a problem of your laptop.
No. Okay, let me make this 21. Maybe better, I don't know. Yeah. So basically you create 3 basic agents, like query agent, trivial agent, generative agent, and then you pass it around, and then Embody has this endpoint that it creates an agentic RAG for you, and then you can basically send the stream down. And then in your front end, how you handle it, basically you have different type of states. The first state would be basically, this is up to you how you want to name them, how you want to basically label them, but it's important that you think about them. So for example, in here I have 7 different states, but the 5 ones are critical here. Understanding, that's where you want to understand the user query. User query comes in, but you want to extract parameters that you can map it to the database and execute a retrieval query. And the retrieval process, that's where we go and find the relevant information. Based on that, the third state is the generation. That's when we call it thinking. You can call it whatever you want. I think OpenAI call it thinking. That's where the response is getting generated. If you have validation in place or valuation, like if the result that's coming back from the model is good or not, that also usually takes time. And finally, show the result or whatever you want to generate, follow-up questions, etc. I think, yeah, this is what I wanted to just share today. I hope it was helpful. Any question? I'm here. Thank you.
I have a quick question. How are you saving the contextual data? Is it in a JSON format, PDF document?
The contextual data?
Like for RAG, we have a document based on which we answer the question.
Yeah.
So that document, is it a PDF document or JSON file?
It's a graphical. In this particular case, this comes from Embody GraphQL endpoint.
GraphQL.
Yeah, so something like this. Not great. Something like this. This is the response.
Okay.
But it's an API in that case. Yeah, thank you so much. You can get the code that of the demo that I just showed you here on the left. And we actually, it was last AI Tinkerers or one before?
Yeah, one before.
One before. So 2 AI Tinkerers before. In AI Tinkerers, we launched the first open source version of Embody. So it's alive, and yeah, please go ahead, give us support, or if you are curious what it is, you can dive into the code.
What if the link doesn't work?
Yeah, it's 404.
Oh shit.
The code.
Yeah, old one. Okay, I can, well, GitHub, on-body.
I have one question. Did you build the rack, like the backend of that, all yourself, or are you relying on other open sources to build the rack, like
No.
vector databases and all these things?
RAG is one of the use cases of on-body. We are using some tools out there. For example, the database for our cloud version is VV8. For example, file parsers, or for some file parsers like PDFs, we do use third parties. But in general, like 80% of the modules are natively built.
And do you support other file parsers as well? Because parsing PDFs and tables can be very complex.
Yeah, our open source does. Our open source version does, not the cloud version. Yes, because the cloud version is one step behind in terms of architecture.
And is the use case specifically the UI part of it? So that becomes really smooth and very user-friendly?
No, it's the backend. Again, the presentation today are the on-body.
On-body.
On-body is the backend only.
Got
It gives some utilities like query parser and such, but again, it's up to you how to render the UI and. Yes.
Could you talk a bit more what's happening under the hood? So what actually is streaming from the backend to the front end for these different states?
Yeah, sure. I mean, okay, let's go back. So for example, here, this here. For example, here, right? The result of this query parser is a JSON file that I define it as basically, let me show you the code. So there is nothing really behind it. It's a simple structure output. So here you define some sort of a ZAD schema and you say, hey, user query comes in, I love pizza, right? So now go ahead and extract these parameters from this user. So the output of that stage, stage one would be concepts, intent, is it relevant or not, and from the context, is it technical, requires details, need example. And these are arbitrary definitions, depend on your use case. But the output of this model, and for this we are using basically on-body JSON generative endpoint, which is like this behind the scene. This is one of the utilities, but this is behind the scene. So on-body generate JSON, and basically with this you define the role of the system, prompting, etc. But you can also then define the schema, what type of a schema that the model returns. So this endpoint returns this particular schema. So this would be the behind the scene of the first event. Here, event one. Then event two is basically when you get the data. And that could be, again, with payloads and everything, it's like a JSON file that you basically do whatever you want. But again, if you use, for example, what I showed you here, that RAG agent, it encapsulates all of this together so it happens in a shared context. But usually if you want to do it, so you first need to do the parsing query, then retrieve the data, then get the information that you want, then you combine, and then rerun query is again another thing.
I guess there was, but then for the last one where you stream the completion, is it then a different output generator, or how does it work? Because then I guess you already stream as the tokens come in.
Mm-hmm. Yeah, so basically for that it depends on what type of API you are using. You get a stream back. So you need to basically work with the stream.
Is the workflow, is it unidirectional or bidirectional? Like,
Sorry?
Is the workflow which we are looking at, is it unidirectional or is it also bidirectional? For example, say if something happens at validator and the flow failed, or maybe it validates that it's not the correct response, which the score is low. So does it go back and do the flow again?
You can. You are in charge. You need to implement it. Again, these are more like conceptual diagrams. How you want to how you want to implement it is up to you. So yeah, so basically again, in on-body it does it automatically, but of course you can set a retry mechanism that okay, if the validator is not, or the output is not good, then send it back and generate again. That's what exactly, for example, cursor does. That it evaluates. Okay, I found, for example, links error. So let's review again. But it's up to you. And there is no one formula that works. It depends on the use case.
So one more question. So how can we make sure, like, I thought you mentioned something about consistent responses.
Mhm.
So how can we make sure the response is always consistent when we are using that?
Unfortunately, I guess Mohammed also mentioned it. There is not really no guarantee, but you have as a developer you have some parameters to work with. For example, the temperature type of model. This JSON output is helping a lot in our use cases that we see with our clients. That JSON output is way more reliable than text output. So these are ways you can control, but at the end of the day, there is no guarantee that you can. And of course, another thing, and why the JSON file is really good in this sort of cases. Maybe I don't use it here, but let me see if I can find N2. Maybe I have it on cursor. So yeah, you see, for example, here, this is helpful. Why? Because in the JSON schema, you can define enums, and then you are limiting the options of the model, and you say only returns among these options, otherwise return no, right? So this way you can also control it as well. This would be a good technique.
All right.
Cool, thank you.
Thank you.